Boyle's law, Charles' law, and the combined gas law. Boyle's law says that if you have a gas and you start compressing it, what's going to happen to the volume? Well, it makes sense that compressed gas would take up less volume than an uncompressed gas. So we can write that in law as PV, and we can either say 1 or I can say I for initial equals P final, volume final, or P2, V2. To go back to regular math, you would say that, say you have 2 letters and you multiply them together and they get 100. And you want the value to stay 100. If you increase one of the letters, say before it was 5 times 20 equals 100. If I increase this 5 to 10, what has to happen to this 20 to still stay 100? Well, it has to go down, doesn't it? So if one letter goes up, the other has to go down to keep the same value. So this is what the picture's saying. If the pressure goes up by compressing it, then the volume has to go down. Okay. Now, Charles' law talks about gases too. And it says that volume initial over temperature initial equals volume final, or 2, over temperature final. What this means is if I heat up a gas, let's put a little flame under here. So if I heat this gas up, we're actually just moving energy into the molecules, aren't we? And what happens when we move energy into the molecules? They start going faster, don't they? When they start going faster, some of them are going to hit on this compression piece, and it's going to push it up. So we are going from here to here now. So if we increase the temperature, we're going to increase the volume. Okay? Using numbers, let's see how that one works. So if I have like volume over temperature equals some number like 100 again. So let's go with 1,000 divided by 10 equals 100. If I pick one number like the temperature to go up, and I want it to stay 100, what has to happen to the volume? Well, it has to go up, doesn't it? So if I take 100 or 10 and change it to 100, this has to also go up to by a factor of 10 to 10,000. Now, you don't really need to know these individual formulas. I would like you to know that Boyle's law has to do with volume and pressure, and Charles' law has to do with volume and temperature. But you don't have to memorize the exact formulas because we're going to memorize the combined gas law. But here's a trick to memorize which one is the temperature one. When I was a little kid, people used to mispronounce my name and I always hated it. So Boyle, I always imagine that people would try to misspell his name to be Boyle, and he would say, no, I don't have anything to do with temperature. So Boyle is our pressure person. He's under pressure to get his name right. Okay, let's talk about the combined gas law. Okay, in the combined gas law, we're going to put Charles and Boyle's together to be PV over T, and this is all either 1 or initial, equals PV over T, either 2 or final. And we can solve for any of these variables that we want to. Now, the only thing you have to remember is T has to be in Kelvin. And remember how to get Kelvin? We take Celsius and we add 273.15 to it. And that's how we get to Kelvin. So if any time you're given Celsius with these, just automatically change it to Kelvin. There can be a lot of pressure units, and there can also be a few volume units. Don't worry about those. Just make sure that volume 1 is the same as unit as volume 2, and pressure 1 is the same unit as pressure 2. But other than that, whatever they give you is fine. So let's work an example problem. Okay. A cylinder contains a gas at a volume of 30 liters at a pressure of 110 kilopascals at a temperature of 146.9 degrees Celsius. Find the temperature of the gas, which has a volume of 40 liters at a pressure of 120 kilopascals. All right, so we are changing both the volume and we're also changing the pressure of this. So we'll get a different temperature. Okay, let's insert it into before we insert it, remember what we have to do? We have to change the Celsius to Kelvin. So I'm going to take this Celsius number, and I'm going to add my 273.15 to it, and I will get 50101781912 420.05. Now, looking at significant digits, I'm only given 2 here. So I am going to first, this would be where if I was just adding and that was all, I would mark it off there and roll it up to 1. But with my 2 over here, I'm just going to take my 420 and put that in for my temperature. So, what's my first pressure? My first pressure is 110. What is my first volume? It's 30. What is my first temperature? 420 Kelvin. And then my second pressure is 120. And I really should be putting my units with everything. My second volume is 40. And then my second temperature is my unknown, so I'm going to leave that at T. Now, in your calculators, go ahead and do this side of the equation. Multiply that out first. and then either put it in parentheses in your calculator or go ahead and press enter, and then divide it by 420. Then take that answer and put parentheses around these and divide it. Take that answer and divide by these two multiplied together. Oop. Nope, that won't give it to you, will it? Because my t will still be on the bottom. Alright, so let me get an eraser and get some more room. Okay, now I'm better. So, what will I do now? If I multiply both sides by t, I'll have my t up here, and this t will mark out. And that's where I need the t to be. So I want to go ahead and multiply 120 times my 40. And then I want to divide by 110 times 30 divided by 420. And that should be my missing t. And I should, if I did all this right, I should get my final temperature as being 610.91. And that's kind of a lot of significant figures in it. Let's go 610 Kelvin. Okay? Pretty easy equation, actually, if you remember PV over T. And T has to be in Kelvin. Other than that, it's just plugging in numbers and using your algebra skills. Now, every once in a while in the problem, it'll say something like a certain pressure, a certain volume, but they won't give you the temperature. They'll just say the temperature stays constant. That's okay. It's the same number on both sides. We don't know what the number is, but since it's the same number, algebra says that we can just mark it off. So if something stays constant, don't worry about that letter and just take it off after you plug everything else in.